pandemic has changed the way we lived our lives. Masks and social distancing have become a way of life.
As the whole world was coming to grips with the pandemic in the March timeframe, this team was in the midst of preparing for the checkpoint rehearsal that would take the spacecraft only 65 meters above the surface. So we had to rethink the entire way in which we were going to do that rehearsal with only a skeleton crew here in the building and with many of our team members remote.
I think the hardest phase of the mission was in spring of 2020 when the COVID pandemic hit. It was a scary time. And we were exhausted. And I would say probably by April, about a month after the lockdown, I wasn't sure we were going to be able to do it. And it wasn't because of the technical challenges, but it was the stress and the human factors that I was really starting to worry about.
Now, the main event is happening in about an hour. This is called TAG. Can you explain to us a bit why it's called TAG?
Yeah, today we're tagging an asteroid, and TAG is an acronym that describes our sample collection strategy. We're going to send the spacecraft down for a short duration contact with the asteroid surface, anywhere between 5 and maybe as long as 15 seconds. So we call it a touch and go, or tag an asteroid.
And that sample site we're going for today, Nightingale, it's just a few meters in width. Just take a step back for a second and put yourself in the shoes of some of those engineers on this mission. And imagine trying to park a spacecraft on an asteroid 200 million miles away in a space no larger than a few parking spots. As if parallel parking on an asteroid isn't hard enough, imagine also trying to dodge hazards like rocky boulders as you're making your descent down to collect a sample. And on top of that, the team has actually programmed the spacecraft to steer itself down to the surface.
We mapped the surface of Bennu to unprecedented resolution of 2 centimeters per pixel, which is better than what we've done on our own Earth and Moon. So it was a huge Herculean effort to get to this point where we're comfortable handing the maps and the keys over to the spacecraft to get us down into this small site today.
So right behind me is the MSA, the Mission Support Area for OSIRIS-REx. And today it is filled with very excited people, the scientists, engineers, and technical specialists who've worked on this mission, in some cases, for more than a decade. So back there is Gary Napier from Lockheed Martin. He's right in the middle of it all. So, Gary, what's the feeling in the room?
Michelle, like you said, I am just right behind you, about 20 feet. We're here in the larger Lockheed Martin Mission Support Area, where we're operating 6 of NASA's spacecraft around the solar system. 4 of them at Mars, 1 of them at Jupiter, and this one right here, OSIRIS-REx.
So it's important to understand that the spacecraft is actually literally on the other side of the solar system, over 200 million miles away from the Earth. So any signal that we were to transmit here would take over 18 and a half minutes to reach the spacecraft. So when we get these signals back, we're actually seeing things that happened in the past at the asteroid. Earlier, we departed our orbit around the asteroid, so we're flying over the sunlit side of the asteroid, taking images for the onboard guidance system called natural feature tracking. A couple other key events that have taken place already is the spacecraft has deployed its robotic TAG-SAM sampling arm, so the arm is ready, in position to collect that sample. And we've turned on and started collecting science data from one of our science instruments, the Otis thermal emission spectrometer. The spacecraft has already moved into its second natural feature tracking attitude and is getting onboard positional updates as we speak. And I can tell you everything is going exactly according to plan right now. It looks really good.
Now, remember that this is a historic event. Today's endeavor will be the first time the space agency has ever touched the surface of an asteroid, collecting a sample of this pristine ancient material, a scientific treasure far more precious than gold. Let's talk a bit about why working in this low-gravity environment makes it tough to get a sample, because you might think sort of at first you could just take like a robotic claw or a robotic arm and scoop something up, but that's not going to work in these conditions.
That's exactly right. The microgravity of Bennu provides a challenge of sampling that we don't normally face on Earth. You can imagine trying to use a shovel or a scoop on Earth, and the ground pushes against you, but the gravity keeps you on the ground. On Bennu, the surface gravity is thousands of times lower than on Earth, so if you pushed a shovel or a scoop into the ground, you'd push yourself right off the surface. So we had to come up with a technique that worked in the microgravity environment and that could work in this tag architecture, this touch-and-go architecture of just a few seconds long.
So I understand the next big milestone we're looking for here is something called match point.
That's right.
So what happens at match point?
Match point is the final maneuver that the spacecraft performs by firing its thrusters. That's where we become centered over the Nightingale sample site and begin that final descent down to the asteroid surface. And the spacecraft is